Hi everyone, welcome to Vedantu J English. I'm Diksha Ma'am, your chemistry master teacher. And everybody, let me know if I am clearly visible and audible to all of you or not, so that we can start with the session, right? Where we are going to do really good questions of physical chemistry, right, for your JEE Advanced. So everybody, let me know if I am clearly visible and audible to you, and if the board is clearly visible and audible. If you think that board is blurry, then let me know, right, so that we can fix it. I think it's completely fine, right? Okay. Shall we start? Yes, ma'am. Go ahead. Okay, perfect. So I'll be solving some 20 questions now, and every single question will not be like simple. See, simple formula application you already know, right? For that, I'll come up with some different session. This session, maybe you won't be able to solve even one single question, but don't be disappointed by that. This is for those twisted questions that they ask you in JEE Advanced, right? Okay, which are actually doable. They are not very complex, but yes, for one point you will have to think that which formula exactly to apply here, right? So starting off, the first question on your screen is, right, that is, they are saying that the potential of the Daniell cell, okay, this Daniell cell is given to you with zinc and copper electrodes with Zn2 positive concentration is 1 molar, Cu2 positive concentration is also 1 molar, right? Then they're saying was reported by Buckby, Surgeon and mates as E naught is this. Now they're saying that they reported the E naught value as this. This was the E naught value, right? In terms of T, where T is the temperature in degrees Celsius. Now you have to note down this thing that the temperature was in degrees Celsius. Okay, so you don't need to convert it into any Kelvin. Usually we convert things into Kelvin, but here it is in degrees Celsius. That is one mistake that you can do in the exam, right? Next is calculate delta S naught for the cell reaction at 25 degrees Celsius, right? 1 EU, because the answer is given in 1 EU. So they have given 1 EU, that is entropy unit is equals to 1 joule per Kelvin. Okay. So first we will calculate this in joule per Kelvin only, then we will joule per Kelvin is same as EU, so it will be converted into EU, right? Now E naught value is given to you. For that you need to know the value of delta S naught in terms of E naught with the differentiation of temperature, because here it is in terms of temperature, right? So with the differentiation of temperature, this is the value of delta S, that is entropy. This is the formula. What is delta E? Nothing but it is internal energy, right? So delta S is equals to NF delta U divide, or you can say delta E, that is internal energy only. I'll just write it here as well. Internal energy, right? No, that is not internal energy. Wait, minus NF. No. This is not internal energy. This is E naught. Okay, my bad. This is not internal energy. This is electrode potential only. So this is delta S is equals to NF, that is the N factor, right? Now you have to tell me here what is the N factor. E naught value already is given to you. That was not internal energy, that was my mistake. That is cell potential only, right? Now we know that E value in terms of temperature is given to us, right? And this is dE by dt. That means we have to differentiate it. So when we will differentiate, what is the value that we will get? Anybody? When we will differentiate, what is the value that we will get? dE by dt, that is capital T, right? What is the value that we will get? Here, this is a constant differentiation will be 0, right? This is constant multiplied by T. The differentiation with respect to temperature is going to be 1 only, that is dt by dt is nothing but it is 1. So it will be, this constant will be taken out, so it will be minus 0.641 into 10 raised per minus 3, right? This is going to be 2t, right? The differentiation of t square is 2t, right? So simple, it is going to be t multiplied by 0.72 multiplied by 10 raised per minus 5. Okay, what is the value of temperature here? They have given that you have to solve for 25 degrees Celsius. So here I'll put the value of temperature as directly 25, right? That is going to be the value of dE by dt. Now the value of delta S is NF dE by dt, right? Okay. So here N is what? N factor. In the Daniell cell, we know that here Zn is getting converted to Zn2 positive. That means Zn to Zn2 positive. That means 2 electrons are getting lost. Here it is getting converted to Cu2 positive to Cu. So 2 electrons are getting gained here. That means N factor is going to be 2 here. So I'll put the value here as 2, right? N factor is 2. This is going to be 96500. Put these values 2 into 96500. And this is the same thing that I solved here. Put this whole value here and you will get your answer here. Okay, this is not a right step. Wait a minute, let me just erase it. Right, okay, let me just erase it. Here what you will get is things in joule per Kelvin, because this is what? This is joules and this is Kelvin. So you will get the answer in joules per Kelvin. So it will be 2 into this. You will get your answer as minus 54.233 joule per Kelvin. That is going to be your value of EU only. So that is going to be the answer. Okay, because 1 EU is nothing but 1 joule per Kelvin. That is mentioned in the question itself. Right? So that is how you will solve this. Right? Okay. Right? Okay. Is that clear? Yes, everybody. Yes, that is definitely right. Right? You should focus on the questions, right? Rather than chit-chatting. Right? Okay. That is clear, everybody. Next question on your screen. Let us see that. Second question. And those who are asking, ma'am, please don't wear bangles and this and that. Guys, don't worry. Right? Okay. I'm going to take them off in some days. There is some religious thing that I have to do. Right? Okay. So I think everything, personal and professional life, should go hand in hand. So don't worry about that. Right? Now, second question on your screen is, for electrolyte MCl2 in water at 25 degrees Celsius, this is electrolyte MCl2 that is in water. It is 25 degrees Celsius. The following data was given. Now, this, I won't say this was a very tough question. This is actually a doable question that you can easily do in your JEE Advanced, but you have to use, like, you have to see what you have to apply here, right? So they're asking you they're asking you molar conductivity at infinite dilution, right? At this temperature only they're asking you that, right? Now, for this you need to know the relation of that graph that I told you. That is molar conductivity at concentration C is equal to molar conductivity at infinite dilution minus A under root C. Why we are using this particular formula, right? Who will give you the hint here? That is, concentration is given to us and molar conductivity is given to us for two different times. That means when the concentration is 0.16, right, then the molar conductivity is going to be 282. Okay. So if I put it here that the concentration is 0.16. Okay, under root of 0.16 is nothing but that is 0.4. So answer will be 0.4 into a minus. This is infinite dilution, and here delta M is not delta M. Molar conductivity is going to be 282. Right? That is my first equation. Second equation is, here I know that molar concentration is going to be 1. For that, the value of molar conductivity is 240. So I have to put this in the same equation here. This is my this is the value of molar conductivity. I'll put it here, right? The value of concentration is 1. Under root of 1 is nothing but 1 only. And these are the two values that you will get. These are the two equations that you will get here. Now you just have to solve these two equations applying mathematics here. Okay, this is nothing but now you have to solve this equation applying mathematics. What you will do, right? Anything you can do. You can add these two values. You can subtract these two values. Anything you can do here. You can do one thing like they have done, that substituting the value of molar conductivity at infinite dilution from equation 2 to equation 1, and hence you will get the answer of molar conductivity at infinite dilution. It's like two equations you have, x and y you have, you can easily calculate the value, right? Okay, right? Okay. Okay, no worries, no worries, beta. Just focus here, okay? Just focus here. Even my intention was not to hurt you. My intention was just to tell you, right? Because from past 1 month, I'm just one question that students are asking. Like those who know, they know. Those who don't know, right? They're asking, ma'am, why you're wearing these much bangles? So have you ever seen me? Like I know, guys, I'm a teacher. I am not a model, right? That I'll wear bangles and this and that, and I'll do modeling here. No, right? So I'm a teacher. You have always seen me in a very simple attire only, right? So I just got married. That's why in my culture, you have to wear these bangles for at least 40 to 50 days. So I have to do some ceremony. Only after that I can take them off, right? So I genuinely value all the religions, all the cultures, and if my elders have told me something, that I will follow that, right? So that is the only thing, right? Don't worry, ma'am is not going to do any modeling here, right? Ma'am is focusing only on chemistry, right? So identify the appropriate graph between enthalpy and progress of physical adsorption. Now this is a question that you don't need to, like, it's not a time consuming question at all, right? It's based on a very simple thing, right? It's based on a very very simple thing, that is, what is adsorption? So you have a surface on that, when the catalyst or the reactants, they will react on the surface itself, right? That is adsorption, okay, by the process of adsorption. Now one molecule came and they are getting absorbed on the surface, second molecule are also getting absorbed, third is also getting absorbed. So initially if I say this was the surface area that I had, now this molecule is getting absorbed, this molecule, this molecule, this molecule, this molecule, this molecule. Now tell me one thing, is the surface area decreasing or increasing? Right? Okay, surface area is decreasing, is it? Right? Because it's like in one room, you had a very large room. But in that room, already some cousin is, then second cousin, then third cousin, all your friends are there in the room. Now you will have less space because already adsorption is going on. So when the surface area is getting less, so as we progress the reaction, as the reaction is going forward, right, our surface area is getting decreased. That is why the enthalpy, initially there was a large surface. That is why more absorbents can come and do the reaction and they can release energy, right? Exothermic reaction. But in this case, as the surface area is decreasing because more absorbents are getting absorbed here, then the heat of adsorption will also be released is less, right? So that is why option A is going to be the correct answer, that enthalpy, according to the progress as a reaction proceeds, the enthalpy is going to decrease here. So answer is going to be A is the correct answer. Right, very good, very good, very good. Right, so here also it is written, the enthalpy of adsorption depends on the extent of surface coverage. Thus, H decreases as the reaction progresses. So answer is going to be A is the correct answer. Okay, next question on your screen. Let us see how many of you are able to solve this or not. Right, very good. I am happy that you guys are trying. Very good. Now, let us see this. At 1 atmospheric and 273 Kelvin, the volume of nitrogen gas required to cover sample of silica gel. Right, so you have to see which formula, what are things, different concepts will be applied in this question. Right, so this is a pressure, this is the temperature that is given to you. The volume of nitrogen gas required to cover a sample of silica gel, assuming Legmuir monolayer adsorption, is found to be 1.3 centimeter cube per gram, right, of the gel. This is the adsorption that was there, right? Okay, volume was this, right? The volume of nitrogen gas required to cover a sample of silica gel, assuming this is the adsorption, the volume is given to be 1.3 centimeter cube per gram of the gel. The area occupied by nitrogen molecule is 0.16 nanometer square. Okay, you have to convert nanometer into meters also, right? Then, what is the surface area per gram of the silica gel? Okay, surface area per gram of the silica gel is what they are asking you, right? Okay, yes, I hope students, this is, wait a minute. Students, we all know the name of the channel is Vedantu JEE English. Okay, so I'm teaching in English, right? And I feel that most of you already know English, right? Okay, so that will benefit. There is no language barrier when we talk about when we are teaching in English. I see students from different states, right? Okay, so I think that is beneficial for all of you also, right? So now let us solve this question, right? Firstly, we have to see the number of molecules. Okay, firstly we will calculate the number of molecules. Then they have given us the surface area per gram. Okay, so according to that we will solve, right? So let us see number of molecules of N2 per gram of silica gel. Now firstly we have to see, because what they are asking you in that, what is the surface area per gram of the silica gel? Surface area they are asking you. For surface area, firstly you calculate the number of molecules of N2. How many molecules are there? At least you should know, right? So firstly let us calculate the number of molecules. For that, we know that two things are given to us. What is that? Wait a minute. What is that? This much. The area occupied by the nitrogen is this much. The volume is given to be this. Okay. Yes. Avogadro's number is given to be this, volume required by this, volume is given. Okay, yes. Now, if you see this, directly we will solve this with the help of volume, right? Why? Because if you see, we know that number of particles, see, moles are having three kind of formula: given volume divided by molar volume, given mass divided by molar mass, and a number of particles divided by Avogadro's number. They are asking you per gram. For that, we have to calculate the molecule first. So definitely we will apply that formula of moles is equals to number of particles divided by Avogadro's number. Now, gram, you have no information regarding the gram. You have volume of nitrogen gas is this. That means you can apply the formula of volume of nitrogen gas, that is given to be this. And what is the volume? Because this is in centimeter cube, right? That means milliliter only is given to you. So molar volume will also be in milliliter, that is this, right? Now you can equate these two things. N will be equals to 1.3 divided by 22400 multiplied by Avogadro's number, that is already given to be 6. So you don't need to use 6.022. So directly use 6 into 10 raised to 23. That is the number of molecules of N2 molecule. Okay, number of N2 molecules that you have. Number of N2 molecules per gram of silica gel you have covered, right? Molecules, you already know how many molecules are getting absorbed from the per gram, right? Cross sectional area is given to be, it is already given in centimeter, in nanometer square it was given. We have converted it into meter square. Okay. Now, area covered by molecule per gram. We are saying that one molecule is covering, let's say, one molecule. This is one molecule, right? I'll just collect molecules for you here, right? This is the surface area, right? Okay. This is the surface area, right? This is the surface area. One molecule is covering this much area. Two molecule will cover 2 into that much area. 3 molecule will cover 3 into that much area. 4 molecule will cover 4 into that much area. Now I have these many molecules. This is the number of molecules that I have. This multiplied by the cross-sectional area of one molecule will give me overall area covered by those many molecules. Right? Is that clear? Okay. Overall molecules, how much area they will cover? So I'll just multiply these two. I'll get my answer. That overall area covered by the molecules per gram. Right? Per gram, I got the area covered, but they have asked me the surface area per gram only. No? They have asked me, right? Okay. So answer is A is the correct answer. Right? Per gram, what is the surface area per gram of silica gel? Right? So directly we have, see, basically two things were applied here. Otherwise, this question was, I think, good, right? But yes, it may be in the exam you will find it difficult to understand what exactly to calculate first. Okay, because there is no direct formula that we are using here, right? Okay, next question is 65.6 milligram of Na3PO4 contains, now this is a very interesting question, okay? See this question for yourself and let us see how many of you at least firstly try to understand the statement. Don't try to answer it directly. Try to understand the statement firstly, what exactly they are trying to say. So if you see this here, 65.6 milligram of this compound contains 20% of this 32 isotope, 80% 31 isotope atoms, assuming only radioactivity of P32, that means out of these two isotopes, only phosphorus 32 is radioactive, right? If half-life period of P32 is given to be this, which is given in days, okay? Remember, this is given in days. The rate of decay of P32 is nearly equals to which thing, right? Okay. Now, let us see and let us calculate that. Okay, also focus on the units here, right? They are asking you the rate of decay of this much atoms. Okay, phosphorus 32. Firstly, we need to understand how many atoms you have, right? We have no idea about how many atoms we have, but they have given you Na3PO4, the milligram. So can I calculate the moles of Na3PO4? Can I calculate the moles of Na3PO4? 20% of this moles is P32. Phosphorus 32 is 20% of what I'll get here. So firstly, I'll have to solve Na3PO4 here, right? So firstly, focus on that. What is Na3PO4? Now, moles of Na3PO4 is what is given to us. That is given in milligram, 65.6 milligram. So converted into grams, right? That is milli means 10 raised to power minus 3. Multiplied 10 raised to power minus 3 divided by 164 is the molar mass of Na3PO4, right? So I'll directly here write as well. This is weight and this is the molar mass, right? Then this moles, as you can see, 1 mole of Na3PO4 will give you 1 phosphorus because 1 phosphorus atom is there. See, if I say that if the formula would have been Na3P2O4, then I would say 1 mole will give me 2 phosphorus. Here 1 mole is giving me 1 phosphorus. So that means same is the number of phosphorus here, moles of phosphorus. So 20% of this mole is equals to the number of or moles of phosphorus 32 that you will have, right? So here, therefore, moles of phosphorus 32 is going to be, wait a minute, 20% of this thing. So I'll just write it here because here it is written in shortcut. So I'll say phosphorus 32 is equals to 20% of moles of phosphorus, that is 20 by 100. Moles of phosphorus is given to be moles of phosphorus. This is moles of phosphorus. Okay, that is given here. So that is why we had directly solved the moles of phosphorus. Now, once you have solved this, they are asking the rate of decay. Now we will move towards rate of decay because already we know the moles of phosphorus, right? Now we will apply this formula that, okay, number of phosphorus to atoms, moles we got, right? Number of phosphorus to atoms will be equals to, moles is equals to what? Moles is equals to number of particles by Avogadro's number. If you multiply number of moles by Avogadro's number, you will get the number of moles, number of particles of P32. So that will be multiplied by Avogadro's number and you will get the number of particles, or you can say number of phosphorus 32 atoms, right? Now, after this you will say, okay, radioactive decay it is. Now for that, one more thing you need to understand is, there is one more concept that is involved here. Ma'am, how you decided that I have to apply this formula? Okay, that is also one question, right? Till now we have mole concept. This is mole concept. Till here we have mole concept. After this we have chemical kinetics, right? So in JEE Advanced they try to ask question, mixed concepts are usually focused on, right? So here you need to understand that radioactive decays are first order reactions, okay? And they have given you half-life here. So half-life, they are saying half-life is given to you. Half-life is nothing but that is T half of first order reaction. That is nothing but, you can see here, T half is equals to decay constant. Like there we had rate constant. Rate constant is decay constant in this case, right? Usually we write that K is equals to 0.693 divided by T half. Here K is nothing but that is decay constant, right? Okay. So directly you can put the value of T half, but that should be in seconds here, right? Okay. So because, ma'am, how come you are saying that should be in seconds? This is given in DPS, DPS, DPS. What is DPS? Decay per second, okay, per second. That means you have to convert it into seconds, okay. So you have to convert it into seconds. This is days multiplied by hours, that is 24, multiplied by minutes, that is 60, multiplied by seconds, that is 60. That's how you will get the seconds, right? T half in seconds, and rate constant of decay this, right? Directly you can put the values here, right? This will be your value of decay constant, right? Rate of decay will be very simple. That is the number of molecules here. As you can see, since only this are radioactive, rate of decay is going to be decay constant multiplied by number of phosphorus 32 atoms. So phosphorus 32 atoms we have solved here. Decay constant we have solved here. You multiply both of this and you will get your answer here. Got it or not, everybody? Got it? Yes. So 2-3 things you should know. One is, this is, if you say, ma'am, how come you can say number of phosphorus atom is equals to, wait a minute, there it was, number of phosphorus atom is equals to decay constant multiplied by number of phosphorus 32 atoms, right? It is just like this. It is a first order reaction. For a first order reaction, we know that rate is equals to K multiplied by the concentration. So here K is nothing but that is decay constant, and this concentration is of number of atoms of P32. So this is what you have to calculate in both the cases, right? Okay. Next, let us see next question. Okay, next is regarding the statements. Now in these kind of questions, which are statement based questions, right? The tough part is that, ma'am, I can't eliminate the options, right? You have to see every statement is correct or incorrect, otherwise the answer you might give it wrong, right? So let us see that the first question here, first statement is T at infinite and activation energy 0, then K is equals to A. This is, you can see this Ka, infinite, this activation energy, all of this is nothing but Arrhenius equation. Now, who will tell me whether first statement is correct or incorrect? That I expect from you. That I expect that you can easily answer this. So, we know that K is equals to A, e raised to power minus Ea by RT. If I say T is infinity, that means this whole term is 0. That means Ea is also coming out to be 0. E raised to power 0 is nothing but 1. So answer is K is equals to A. That is the correct statement, right? Next is, a positive catalyst can change delta H of the reaction. Now what a catalyst does. This is a catalyst. See, the statements are not difficult. Statements are not difficult. To choose which of the following is correct, that is the difficult part. Whether 2 are correct, 3 are correct, you have to choose that, right? So we know that here, this is the reactant, this is the product. Whenever you have activation energy, it changes the activation energy here. It does not change the energy of reactant or product. So delta H will not change. So this statement is incorrect here, right? This statement is incorrect because activation energy is changed. There is no change in energy of reactants and products. Delta H is energy of reactant minus energy of products. Okay, so that will not change. A mixture of reactants may be thermodynamically unstable but kinetically stable. Now, this is, I think, where students might get stuck. Okay, this is what I think you might get stuck, right? Last one, let us see. A negative catalyst increases the activation energy of the reaction. That is true. A negative catalyst will, for example, this is the bar firstly, this is the barrier, right, that you have, right? A negative catalyst will increase that barrier. A wrong teacher will lead you in a wrong direction. A right teacher will lead you in a right direction. They will decrease the barrier, right? Okay, so that is also correct. Now the question is, statement, statement, statement. C is correct or incorrect. Okay. Let me see how many of you are able to answer this, right? Okay. Yeah, let us see. If you see there's a mixture of reactants, that is actually a true statement. Right? Let us see with the help of an example. Rusting of iron is thermodynamically favorable, kinetically quite less favorable. Thus, we can say mixture of iron, oxygen, water is thermodynamically unstable, right? And kinetically stable, right? That is why this statement, according to that equation, will become correct here, right? So, C is going to be also the correct answer. So answer is A, C, D, all are the correct statements and B is the incorrect statement here. Right? Okay. Next question on your screen is regarding solid states. Okay. That is there. That is there in the exam. Right? Okay. Okay. Now, the packing efficiency of a simple cubic crystal with an interstitial atom exactly fitting at the body center. This one is very interesting. Okay, so I have to firstly explain you what exactly is because that was not there in JEE mains. So chances are you might not even have even learned this concept, right? So if you are that student who has never learned this concept, then see this. A simple cubic crystal is where you have atoms only on the corners. Okay, this corner, that corner, that corner, that corner, those four corners and those four corners. In all the corners of your room, you have one atom, right? Each atom will contribute 1 by 8, right? Reason is because it will be shared by 8 rooms. The atom that is at the corner of your room, that will be shared by 8 rooms. 4 rooms in the first floor, 4 rooms on the second floor. Okay, that is how that atom will be shared, right? Now here, they are saying that you have a simple cubic crystal. In that case, the atoms are contributing like this. Okay, the atoms are contributing like this. Okay, now what you have drawn here, this is that 1 by 8th part of the crystal. Okay, 1 by 8th part, this is the 1 by 8th part, 1 by 8th part, 1 by 8th part, 1 by 8th part, right? Okay, that is your SCC, simple cubic crystal. Now, here we know that this is called the edge length, right? So A is equals to 2R. What is R? R is the radius of the cubes, radius of the atoms that are there at the corners. So this is the radius plus this R. So it is going to be A is equals to R, 2R. Is that correct? Is that clear, students? Now I will draw one more diagram. I will draw one more diagram here. I'll just draw it here, right? Just draw it here. Now you tell me what is the diagonal. Now what they are saying, there is one atom in the center, which is perfectly fitting in between the voids that are present inside that cube. Okay. Now see one thing from this. The diagonal is, you're saying your room now, right? Okay, when you see your room, this is one wall. Okay, this thing is the diagonal. This thing is the diagonal. When I'm talking about only that face, only that particular face I am talking about, like this face, this length to this length is my diagonal, right? But if I see the diagonal in a cube from this corner till that corner, right? From this corner till that, let me see if I have something from which I can explain you that. Let me just see that. Let me just see that. If I have anything like that where I can explain you that thing. Currently, though, I don't think so. I have anything in square, right? Oh. Oops. think I did something wrong. Chalo. I don't have currently anything, but I have this book. Right? Okay. Now, I am not saying this diagonal. I am not talking about this diagonal. This diagonal on that plane. I am saying that from this point, or you can say from this point, inside it, touching this point. From this point, touching till this point. Okay. That diagonal. Okay. That diagonal which is like this. Which is like this. Not like this. Not on one plane. It's like this. Okay. Understood? Understood or not, students? I don't have anything in square, otherwise I would have explained you in a better way, right? I'm still looking for something which is in square, but I don't have Hanji. Okay, so that thing from this point till this point, okay, that is the diagonal that I am talking about. This is the diagonal of one plane. This is the diagonal that is inside the cube, right? Okay. This diagonal is equals to under root of 3 and the edge, this edge length of all the lengths of that cube is A. So under root A, right? Now, if you see inside this, what are the different things that you will have? Here you will have corner of atom, corner of atom. Here you will have one center. They are saying that interstitial atom exactly fitting at the body center, right? Assuming that the radius of the interstitial atom is, let's say, capital R, you can take, okay? You can take capital R plus this is small r into 2. Why we have done? Because this small r, and this capital R, and this is capital R. Okay, that is 2 into capital R plus small. Is that clear to everybody or not? Are these two statements clear to you? If these two things are clear to you, then nothing, everything else is very simple. Okay, these two things you can directly cram these two formulas as well, but if you understand, that would be better for you, right? Now, if you put this value here, that will come out to be under root 3, 2, this is R plus R, and this is 2, right? This is the equation that you will get. Now here they have taken this capital R as X, so I'll also take it as X only, right? Because I don't want to write it again and again, right? To save your time only, right? So I'll also write it as X only, okay? You can take it as X. Now, this thing is clear. Now, if I calculate the packing efficiency means in this cube, what is the volume that is occupied by the atoms, okay? So that will be volume occupied by the corner atoms plus volume occupied by this interstitial atom. For that, you need to calculate the value of X here in terms of R. Okay, so calculate the value of X solving this in terms of R, right? So here we have calculated the value of X in terms of R, and that is the value what you will get after solving, right? Now packing efficiencies by the corner atoms. We know that corner atoms, we have 8 corner atoms, and each corner atom is giving 1/8 fraction of the contribution to one room. Okay, so that means 8 will cancel out each other. So directly you will have volume of that one atom, and volume of any sphere is 4/3 pi r cube. So I'll directly put 4/3 pi r cube. R is the radius of the corner atom. Now plus addition with 4/3 pi x cube. What is pi x cube? This is 4/3 pi x cube. What is x cube? X is the radius of the interstitial atom that is inside that cube. Okay, so that is going to be 4/3 pi x. You have calculated in terms of R. You put the value here. R will cancel each other eventually. Pi will cancel each other. Okay, so R cube will cancel each other, and here you will get your answer in simple terms. Okay, got it or not? Right? Okay. Okay, students, is that clear? So answer is going to be C is the correct answer. I hope so this is clear to you, because this is also a very important question for your JEE Advanced. Right? Okay. Next is a different question that is based on solubility. Right? Ready for the next question or not? Solid state, I really doubt if I have taught it. No, I don't think so. I have taught it, right? Okay, but don't worry. I'll make a video on the formulas of all these things. Okay, before your JEE Advanced. Don't worry about that. Right? A quick recap of these the chapters that were not there in JEE Mains, but they are in JEE Advanced. Right? If you want me to make a simple short video on that, right, all the chapters, the important points of that, then you can let me know in the comment section. Then I'll make that. Okay, but only if you actually want it. Right? If you don't want it, I'll not do that much hard work then. Right? It totally depends upon what you want. Only then I'll spend my time making those notes for you, because handwritten notes are a tough thing to do, right? Okay, seeing my schedule right now, right? So here is saturated solution of HCl3, right? Has a vapor pressure of this mmHg at 20 degrees Celsius, while pure water vapor pressure is this much. Okay. Saturated solution vapor pressure is this, pure vapor pressure is this. Solubility product of X. Now again they have, two concepts they have picked up, right? One concept is vapor pressure, right? Other concept is your KSP. So first you have to solve the value of, see, in vapor pressure, you can solve now because they have given molality here. We know that, okay, let's do reverse of this question. Okay, let's do reverse of this question. As I told you, in JEE Advanced, mixed concepts are asked to you. Okay, so two mixed concepts again. HCl3 will give you X3 positive plus 3Cl negative. First, you tell me what is the value of KSP. This is 1, this is 3. So it is 1 raised to power 1, 3 raised to power 3. Solubility of this, that is 4. Right? So it is going to be 27S4. Right? That is the KSP. Solubility here, nothing is this, molarity only. Right? Okay. Now they are asking you solubility product. Solubility is nothing but molarity. Molarity here is nothing but molality. So can I write it is equals to 27 molality raised to power 4. Now, if from this information I am able to calculate the value of molality, I can put the value of molality here and calculate the value of KSP, right? Understood? How I did this, first you have to see. That is stoichiometry raised to power stoichiometry. Stoichiometry raised to power stoichiometry. In JEE Mains, till here they ask you the question. In JEE Advanced, they will also include one more concept and make one new question. That is the difference. Okay. So, here you have to calculate the value of molality, right? Okay. Very good, very good. Molality and molarity are same. So, you can calculate the value of molarity from here. That is relative lowering in vapor pressure, right? That is equals to I Van Hoff factor, right? Now, if you see Van Hoff factor, they are saying Van Hoff factor, this is the dissociation only. After dissociating, it is going to give you 4 molecules. So, I is going to be 4. Because here they have not given anything about the dissociation. How much dissociation? Will take the dissociation as 100% only, right? So, Van Hoff factor is 4. This is N of solute by N of solvent, right? What is that? That is the mole fraction of, that is directly equal to mole fraction of the solute. That is mole fraction of solute by mole fraction of solute plus solvent. In comparison to solvent, solute is very less, so it will become number of moles of solvent only. Now, if you multiply both of them by molar mass of solvent, then multiply and divide by 1000. Now, can you see this is nothing but, wait a minute, this is nothing but this is molality. Can you see this is nothing but molality? There is also a direct relation, but you don't need to learn these formulas, right? So directly you need to know that, okay, you can convert it into molality, right? So this is nothing but molality only. So I into molality, molar mass of solvent by 1000. Solvent is already given to us that it is a saturated solution, right? So basically we are talking about that it is a water solution, right? So that is, it is 18 is the molar mass of water, 1000 molarity. You can easily calculate that is equal to nothing but molarity only. I is 4, and these all things are given to you. What is the pure vapor pressure? What is the vapor pressure of the solution? Put all the values here, right? And you will get your answer for molarity and molality. Molality, which is equal to molarity. You can put this value here and you will get your answer. Molarity or molality is coming out to be 0.04. Put this value here and you will get your answer for KSP. Okay? Understood? Understood, everybody? Two concepts combined, right? Next question, let us see. Now, this I would say is actually a good, simple question, and I really expect you guys to answer this, right? Let me see how many of you are able to answer this. Algo, electropositivity, Gundu, Mali, Ojas, yes, bring some inorganic chemistry for advanced of block chemistry and metallurgy, please. Now, okay, Ojas, I'll definitely do that. Don't worry about that. Don't worry, I'll definitely do that. Okay, don't worry. Okay, now let us see column 1 and column 2 contains 4 entries each. Entries of column 1 are to be matched with some entries of column 2, right? So here it's not a very difficult question. It's just that these things may be different for you. These things may be different for you. So if you talk about the first one here, elevation of boiling point is a colligative property and it is elliptoscopic constant also, that is KB is also there. So A is P and Q, A is P and Q, A is P and Q. So D option is eliminated. Osmotic pressure is a colligative property. B is P, B is P, B is P. Yes. Then osmotic pressure is also measured by Becquerel-Hartley method. So answer is B is R also. That is B is R also is only there in option number A. Then relative lowering in vapor pressure is also a colligative property. That is C is also P, right? And this is also measured by Oswald and Walker method, right? So answer is C is also S. D is depression in freezing point. That is only a colligative property. So answer is A is the correct answer. Okay, A is the correct answer. It's just that here to either you will know the answer or you will not know the answer. There is no mixing of the concept. It's just that some important facts beyond your NCRT they have asked, right? Okay, so some things beyond NCRT you should also know for JEE Advanced, right? Next is all the properties given in colligative elliptoscopic constant is this. Becquerel method is used for measurement of osmotic pressure. Oswald and Walker method is used for measurement of relative lowering in vapor pressure. Okay, wait a minute. Depression in freezing point. Wait a minute. Wait a minute. Wait a minute. Oswald and Walker method is used for measurement of relative lowering in vapor pressure. Yes. Okay. Yes. C only at IGNA. That is yes. Okay. Right. Got it. Now, next one is Cl2 disproportionate into this and this ions in hot alkali. Which equivalent is wrong about this reaction? Now, this is from the redox reactions. Now, let us see redox reactions, usual N factor calculations we know. But here they have asked you N factor calculation in a very interesting way. So, you have to know this as well. Let us see that. Cl2 disproportionation. Okay. Cl2 disproportionate into these two things. So we know that Cl2, this is 0, Cl negative, ClO3 negative. Now ClO3 negative is x minus 6 is equals to minus 1, that is x is equals to 5. So here that is why here it is written plus 5 and here it is written minus 1 and here it is 0. oxidation states is clear to us. Here we can see that if you see the n factor of each, here one chlorine atom is losing 2 electrons, 1 electron, because 0 is getting converted to -1. No, it is gaining 1 electron, right? One chlorine atom is gaining 1 electron here, right? Two chlorine atoms will gain 2 Cl here, right? So that is why n factor is 2 here. In this case, n factor is 2. You have to be very clear on these things. 1 Cl is getting converted from 0 to +5. 2 Cl will get converted to 0 to +10, right? That is multiplication with 2. That is why here n factor is 10. Okay, first important point. Second is, one by one we will see the statements here. Equivalent weight of Cl2 is 60% of that of molecular weight. So equivalent weight of Cl2 total you have to calculate. So total n factor in these two cases, together n factor is going to be, since chlorine is undergoing disproportionation and in disproportionation, the n factor is n1 n2 divided by n1 plus n2. That is the formula of n factor here. So that is why this is 10 multiplied by 2 divided by 10 plus 2, that is 12, that is 5 by 3. Right? Now equivalent weight is molecular weight, that is 71, divided by n factor, that is 5 by 3. So that is going to be 42.6, which is 60% of molecular weight, that is 60% of 60%. Okay, you have to solve the 60% of 71 is going to be 42.6. So 60% of molecular weight is nothing but your equivalent weight. So that means first statement is the correct answer. Okay, first statement is correct here, right? Second statement is, first statement is correct. Equivalent weight of oxidized chlorine is 7.1. Only the one that is getting oxidized. Only the one that is getting oxidized. So oxidation is when 0 to +5 it is getting into. So 1 chlorine is getting into 0 to +5. 2 chlorine will be from 0 to +10. So n factor is 10. Equivalent weight is nothing but that is 70. 1 divided by n factor is 12, that is 7.1. So is that the correct answer? Equivalent weight is chlorine is 7.1. That is also the correct answer, right? Okay, that is also the correct answer. Now third is 5 by 6 fraction of total chlorine is reduced. How much fraction is getting reduced? For that we have to divide it with the original one. Okay, so first is, third one is, this we have done already. See, this is the formula, this is the reaction that you have. For first you have to balance it because you are calculating the fraction. Once you balance it, other things will already be easy for you. Balance this. This is 2, this is 2, oxygen is 3. So you have to firstly balance all of this together. And this is the balancing of equation that you will get. Right? 12Cl2 plus 10Cl2 ClO3 negative. Right? Okay. That is the balanced equation that you will get. Right? How you got this balanced equation? This is obviously by balancing oxygen and hydrogen also. Okay. So after balancing, what you see is fraction of Cl2 reduced. How much it is reduced? Reduced means this part is the reduction part. So this part is the reduction part. That is 10 has left and originally it was 12. So it was 10 by 12, that is 5 by 6. So that means 5 by 6 was reduced, right? Fraction of Cl2 oxidized. Oxidized means this part and this part. So out of 12, 2 we are getting here. So that is 2 by 12, that is 1 by 6. Right? So that means B is the incorrect answer because they are saying that 5 by 6 fraction of total chlorine is oxidized, but in reality it is 1 by 6 fraction is getting oxidized. Okay, and you know what? Even if you don't know any of them and they are asking you which is the incorrect statement, see, logically, if I am saying 5 by 6 fraction, 5 by 6 fraction, the total fraction should be equals to 1. So either this can be 5 by 6 or this can be 5 by 6. So directly you can solve this or this also. You will get your answer, right? Okay, because the total, either they should have given us 1 by 6 here, 5 by 6 here. In that case, we could have answered it like we could have, this question can get more complicated. But here we can get a hint that 5 by 6 here, we have 5 by 6 here, we have total fraction should be 1. That means and one of these statement is going to be incorrect here, right? Okay, that is also one hint that will ease the options for you. You can eliminate the options in the exam, right? Next is identify intramolecular redox reactions, but not disproportionation reaction. Okay, so here what you have to do is you just have to see that which is getting oxidized, which is getting reduced. Like in the first part, you can see oxidation number. Here, nitrogen is getting oxidized, nitrogen is getting reduced, Cr is getting oxidized here. So it is intramolecular redox reaction. Here we have, if you see in this case, it is a comproportionation reaction. Okay, this is comproportionation reaction. Okay, not disproportionation, but this is comproportionation. Plus 3 is getting oxidized, plus 5 is getting reduced also here. So that means N is oxidized as well as reduced. So it is definitely a redox reaction. Next is, if you see this here again, this chlorine here is getting converted to -1, right? Okay, and oxygen is -2, here it is 0. So here oxidation state, you can see not chlorine, it should be Cl here, right? Okay, Cl is getting reduced and this is getting oxidized -2 to 0. So that is why it is definitely intramolecular redox reaction. One is getting oxidized, one is getting reduced. In this case also, phosphorus is +5 here. Here phosphorus is +3. Here chlorine is -1. Here chlorine is 0. So it is getting reduced. It is getting oxidized. So again, it is a redox reaction. So answer will be A, B, C, D. All of them are redox reactions. Okay, understood? Next question on your screen. Next question on your screen, everybody. Next question, everybody. Are you ready for this? Ready for this question? Yes, ma'am. Okay, great. Okay. A small particle of mass m moves in such a way that potential energy is this. Now, two kind of questions I have picked up here regarding this, right? Two kind of questions I have picked up here regarding this, right? Because for the first time, you may find it little tough. Otherwise, this is not a tough question. It's a very simple question. It's like a derivation only. Okay. So a small particle mass m moves in such a way that potential energy is this, where k is a constant, r is the distance of the particle from the origin. Assuming Bohr model of quantization of angular momentum, that means mvr is equals to nh by 2 pi. They are saying this is applicable here. Okay. And circular orbital, okay, model of quantization, angular momentum and circular orbital, r is directly proportional to which thing? Okay, you have to calculate the value of r in terms of n, right? Okay. So n I'll see from there. This is PE. So firstly, what we will do here, right? What we will do here, potential energy is given to us, right? So here in this case, first you will do potential energy is differentiated by r, and this is the magnitude of force that you will get, right? Whenever you are given with potential energy, differentiate it with respect to r. Other things are constant, right? Mass is constant, k is definitely constant. This will be mk. Okay, wait a minute. Here it was half mk. Wait a minute. When I differentiate, I'll just differentiate it here. So this will be half. This is 2. This is mkr. So answer will be mkr. Okay. After differentiation, answer will be mkr. That is the magnitude of the force. Now they are saying that the centripetal force is equals to the magnitude, that is mv square by r is equals to magnitude of the force. that is mkr is equals to nothing but it is centripetal force only, because electron is revolving around the nucleus, right? So till here you don't solve anything, you know this thing. And they have also told you that Bohr angular momentum is applicable here, that is mvr is equals to nh by 2 pi, right? Okay, this is also applicable here. This they have already told you, right? Assuming Bohr model of quantization and angular momentum and circular orbit. That is why we are using centripetal force here, right? Now you have these two equations. This equation you have and this equation you have, right? It's totally your choice how you want to solve the value of r here, right? In both the cases you have r, in both the cases you have v. You can do anything. You can divide these two things, right? But if you divide these two things, you will not get the value of r here, right? You can also do one thing. You can divide these two things, just like here, calculate the value of v square, put it here, and you will get the value of r, right? Somehow you have to get the value of r. You have to ignore all the other constant here and just see that it is getting directly proportional to under root of n. Totally your choice how you want to solve this. Okay, totally your choice how you want to solve this. You can divide these two things, right? Then this will be okay. From here also directly you can see, because this m and m will cancel out each other, right? This will be r square v square by k, right? And here you have mvr nh by 2 pi. What you can do is you can solve the value of v here, that is nothing but v is equals to nh by 2 pi, and this is divided by 2 divided by mr, right? You can put this value here, right? So v square will be nothing but the square of this. You can put the value of v square here, and what you will get is that r square, that is r raised to power 4, because here it is r square, right? This is v. When you put the value of v square, this is the value that you will get. This is r square. That means v square is directly proportional to n square by r square. Now you put this value here, that r square is directly proportional to v square is given to be n square by r square divided by k. That means r raised to power 4 is directly proportional to n square by k. That means just erase this constant here. That means r raised to power 4 is directly proportional to n square. That means r raised to power square is directly proportional to n. So r is directly proportional to under root n. So this by proportionality sign also you can solve this rather than solving it with the values. Okay. So that is r is directly proportional to under root n. So C is going to be the correct answer. Now if you solve these kind of questions for the first time, you will be like if I give you this question in the exam itself, you will have no idea how to solve this. Not because you have done this question, you will be easily able to do this in the exam. It's not a tough question if you have already solved these kind of questions, okay? But yes, if you've never solved this, then definitely these kind of questions are going to be tough for you, right? Okay. Next is same kind of thing. Now this question I have picked up just to make you comfortable with these kind of questions, where for a hydrogen, hypothetical hydrogen-like atom, potential energy of the system is given by this. Now, doesn't matter what is the potential energy given to you, right? R is the distance between two particles. The Bohr model of quantization of angular momentum is applicable. The velocity of the particle is given by what? Bohr angular momentum is again mvr is equals to nh by 2 pi, right? Again this thing. From there, here also you will solve one thing which will be equal to centripetal force here. So directly you will do the same thing. Solve this value, differentiate this, and what is the answer you will get? This is minus k e square by r cube, right? Differentiate this with respect to r. So this will be minus of k e square r raised to power minus 3. Differentiate this. It will be minus k e square. This is minus of 3. This is r minus 4. That is nothing but k e square by 3r raised to power 4. This is what you will get, that is du by dr. This is the ke square by 3r, ke square by, wait a minute, why it was 3? Acha, 3 was there only, na? 3 was there in here only, that is 3ke square by r raised to power, right? 3ke square by r raised to power 4. This is what you will get. Equate this with the centripetal force because electron is revolving around the nucleus, so in a circle. So it is, this is done. Now we know that this is also given to us. Now, anyway, the way you like it, you have to solve the value of V in terms of N, because in the option, they have given you this in terms of N. So they have asked you direct formula only. Now you have to, solve this fully, right? Without like putting the values, you have to solve this, the value of V square. So what we have seen is V square is directly given to us. So if we are able to calculate the value of R here, so that means V square is nothing but 3ke square divided by R cube. This is M. Okay. So R value you have to put here. R is nothing but that is NH by 2 pi. This is MB. So R value, you will put the value of R here and you will get your answer here. Right? You will put the value of R here and you will get your answer in terms of not R but the other things, because you have to substitute the value of R. R should not be there in the formula of V. Right? Okay? Easy. Will you be able to do these kind of questions in the exam or not? Everybody, yes or not? And those students who actually want to know that, ma'am, when are your sessions, like all the sessions, frequently when you take the sessions, where, and where you inform all these things. So that is over here. You will see this Telegram channel, t.me slash Diksha Kaushal Chemistry. That is my Telegram handle. You can go and connect me over there. We will get all the details of my lectures there. Right? Okay. Now, this is a very, very interesting question. Very, very interesting question. Let us see that. On your screen, we have this. So, here what they are saying, there is this pipe, right? This is the open vessel. This is the open area here, right? And now we are saying that initial pressure is 75. 75 is the initial pressure. 24 is the amount that we are left with here, right? 10 centimeter of Hg. This is basically the atmospheric pressure that you have. This is 10 centimeter of Hg is the pressure of this area here. And this is 10 centimeter, this is density. This pressure we don't know, right? But here we know that the volume is 20, the area here, basically the length of this is 24. Okay, so what you have to see. Okay, one by one, how to solve these kind of questions. Firstly, here you will use Boyle's law, that is P1 V1 is equals to P2 V2. Right, P2 V2. This is what you have to apply here. Right. Now, in this case, you have to firstly select what is P1, what is V1, which is P2, what is P2. Right. For that, because here the volume is related to this 24 centimeter. This is the amount of length, or you can say whatever is left here, right? Or you can also say this is the height, because they are saying in the above tube is placed vertically with the open end upwards. That is, if it's placed like this, if it is placed like this, right? Then this 24 will become the height, right? So that is why this is nothing but the height. Okay. So that means the volume initially, V initial is going to be 24 into the cross-sectional area, which I will take it as A. Assume temperature remains constant. Here I am assuming the area of cross-section as A, right? Now, here what is the initial pressure? What is the initial pressure here, anybody? What is the initial pressure that is important? That is 75, as you can see. 75 is the initial pressure, right? What is the final pressure? Now, final pressure is very important, because in final pressure, the volume is already decreasing. Final volume is when you will tilt this vessel vertically, then this will go downwards, and this much, let's say x centimeter is what we are left with. So I am saying that the final volume is x into A. A is the cross sectional area. X is the height when you are applying that pressure. Now, here you have this atmospheric pressure. But in this case, when you are moving it vertically, this pressure and this pressure will get added on here. And hence, what we will have, the final pressure is 75, that is the initial pressure, plus this. Now, what is all these two things? See, this is the pressure, this 10 is the pressure that is given to us for this area, right? For this, whatever liquid. So basically 2-3 liquids we have here, right? Usually it is like this is oil, this is mercury, these kind of questions what we have seen usually, right? So here this is, what we have is 10. So 10 centimeter of Hg means they have given the pressure only. So that means we have added 10 here. Ma'am, what about this area? That means this area. How we will identify the pressure here, right? So pressure is nothing. The length that is given to be 10, the density that is given to be 20.4 divided by the pressure of mercury that is given to be the standard pressure of mercury, that is 13.6. Okay, so that is how you will calculate the pressure in these kind of cases. That is the length multiplied by the density divided by the pressure in the standard mercury, that is 13.6. That is how 10 into 20.4 divided by 13.6, that is the standard pressure of mercury, right? And here you will get the value of final, P final you have here, right? V final is also here. So now you just have to equate these two things, that is P1 V1 is equal to P2 V2, and applying the Boyle's law you will get the answer. Let's say P1 is what? P1 is given to be, P1 is given to be 75, V1 is given to be 24 into A, right? P2 is given to be, V2 is given to be X into A, P2 is given to be 75 plus 10 plus 20.4 multiplied by 10 divided by 13.6, and that is how after solving you will get the answer for X here, right? And what they are asking you here, if above tube is placed vertically, then length of the air column will be, air column is this length is going, that we have taken as X, right? So answer is X is going to be 18 centimeter because everything else is in centimeters only. Is that clear? Hello, hello, hello. Hello students, am I visible? Am I audible? Is that clear to everybody or not? Yes, everybody? Is that clear to all of you or not? Right? Next is for 500 Kelvin. Now next, let us see. Next question, let us see that. Yes, we are still left with so many questions. Okay, next question is for 500 Kelvin, plot value Z changes from 2 to 2.5. If pressure is varied from 1000 atmospheric to 1200 atmospheric, then the value of B by RT will be. So now, basically here you have to use a formula of like the variation of ideal gas, right? This is basically from states of matter, when the variation of ideal gas, the equation of real gas, right? So here it is going to be Z is equals to, this is the value of Z, the formula directly, Z is equals to 1 plus PB by RT. Here they have given us that the plot of for the plot value of Z changes from this to this if pressure. Now they are giving us two values. Z is 2 when the pressure is 1000. Z is 2 when the pressure is 1000. Z is 2.2 when the pressure is 1200. So you just have to put these two values here and you will get your answer. For they are asking you B by RT here. You can easily solve the value of B by RT here. All you need to know is this value of the compressibility factor when you have real gas, right? Not the ideal gas. This is for the real gas, right? Okay. So also, what is real gas equation? You should know, right? Okay, all these simple things you should know, right? Because sometimes the things that are not there in JEE mains, they ask very simple questions from those chapters, right? If two gases AB2 and B2C are mixed, now this is the question based on simultaneous equilibrium, right? Okay, so actually this question you will find it very simple, right? The concept is maybe new to you, right? So let us see two gases, we have AB2 and B2C. Now I'll solve it in front of you only, right? So AB2 you have, let's say you have 1 are mixed together, this also you have 1. Let's say at equilibrium X amount we are taking out, X amount we are taking about. This means X we are forming here, X we are forming here, right? Now you are using BC here. BC you are using, that is nothing but X. B2C is nothing but 1 minus X initially. Now you will take, after this reaction, Y amount will go, Y amount will go from this side. Here you will have the formation of Y. Now, see B2C, if here it is 1 minus X minus Y, here also it should be 1 minus X minus Y. So it will be 1 minus X minus Y, 1 minus X minus Y. If BC here is X minus Y, here also it should be X minus Y. Anything else that is common between these two things? Nothing, right? Now they are asking you one thing. In the reaction is started only with AB2 with B2C, then which of the following is necessary to at equilibrium? Okay, so we can take two things here, right? Because they are asking you at equilibrium concentration is equal, greater, all these things. If you say AB3, that is this, is equal to BC, right? This is X and this is X minus Y. How I can tell whether they are greater or equal? They can't be equal because you are taking out Y here. If I am saying that you have 10, right? Let's say this is 10, okay? And you are taking 0 from 10. Only then these two are possible. That means this reaction is not happening. But they are saying both the reaction is happening. That means from this X, you are taking some amount. You are taking some amount. That means this value is not possible. Is that clear? This is not possible. Let us see this thing here, that is AB2, that is the value is AB2, that is 1 minus X, and B2C, that is this thing. They both are equal. This is not possible because again we are saying, let's say 1 minus X is 10. 1 minus X and 1 minus X minus Y, if both are equal, then both the value 1 minus X minus Y or 1 minus X both should have 10 values or same value. That is not possible. That means Y should be equals to 0, which is not possible. If Y is 0, that means this second reaction is not happening, right? So that is the reason this is also not possible, right? Next question, everybody. Yes, next is AB3 is greater than B3C2. AB3, that is this value, AB3, X is greater than B2C2, B3C2, that is Y. Okay, this is the equation that they are saying. AB3 is greater than, AB3 means this thing is greater than BC, that is X minus Y. Is this possible or not? X is greater than Y, that is definitely possible. See, that is possible. It is possible. X is greater than X minus Y, that is also possible. If you take out something, like if I say 10 is greater than 10 minus 2, that is right only, right? So that is also true. So C and D are true here, right? Is that thing, is this question clear to everybody, right? Two concepts, one is this thing, other is verifying the options here. Just by assuming some random values here, right, you can see that two statements, that is C and D option is correct here, right? Next is, at what molar concentration of HCl will its aqueous solution have an H positive to which equal contributions come from HCl and H2? Everybody, let us see that. Where are you students? Where are you? At what molar are you alive? Are you alive, guys? Or you are like, okay, ma'am, we are sleeping. By now, ma'am, we are totally dead. right? Because after this, you are going to have your mathematics class, you are going to have your physics class as well. So you need to have that energy, right? Where is that energy, students? At what molar concentration of HCl will its aqueous solution have H positive, to which equal contribution comes from HCl and water? H positive has equal concentration from water plus HCl. Okay. And OH negative has just from H2. Okay. Okay. At what molar concentration will have equals have H positive, which is equal to come from HCl and H2O. Okay, this is what they are saying. Molar concentration they are asking you. So H positive concentration, let's say if it is equals to X, right? Okay, it is coming out to be X from each, because they are saying that the concentration from water and the concentration from HCl is equal, right? The H positive concentration from both of them are equal, which I'll take it as X. That this is also giving me X amount of H positive, this is also giving me X amount of H positive. This is what they have given in the question, right? So I'll take that H positive from both of them is X, so it is X plus X, that is 2X. Now, if from water H positive concentration is X, then OH negative concentration is also going to be X. So, OH negative concentration is also going to be X from here, right? Now, we know that Kw at 25 degrees Celsius, ionic product is going to be 10 raised to the power minus 40. H positive multiplied by OH negative is going to be 10 raised to the power 40. Right? OH negative is X, H positive is 2X, right? You will solve the value of X here, and that is nothing but that is your answer, right? Okay, everybody, understood, right? Next is for polytropic process, PV raised to power n is constant. Molar heat capacity of an ideal gas is given by which of the following, right? Molar heat capacity they are asking you, it is given by which of the following. So directly you will have to use this formula here. Du is equals to dq plus dw, right? We know that the value of du is ncvm dt and dq is ncm dt, right? Okay, that is directly the molar heat capacity here, right? So this dw is nothing but it is minus p dv, right? We'll put the value of dw also here, right? Okay, once you put all these values, now we know that n will cancel out each other. It will basically, it is going to be, you can divide this by n, you can divide this by dt, and you will get this value, that is cm equals to cvm plus pdv and dt, right? Now they have given you that PV raised to power n is a constant, right? So that is, this value is given to you, it is a constant, right? We also know that ideal gas equation is PV is equals to nRT, right? Now solving these two values, you have to put the value of PdV from here to put it there, right? So now what we know that because this is PV raised to power n is K. So can I say that if I use, let's say I want to calculate the value of, chalo, let's do this way only, right? Here this is P, V raised to power n minus 1, V raised to power plus 1, that is K, right? Okay, if I put this, if I solve this, I'll get the value PV raised to power n, right? Okay, so that means PV raised to power, or if I say this is PV n minus 1, now you have to calculate. I'll solve this not like this. This would make it even more complicated, isn't it? dV by dt you have to solve, right? dV by dt value you have to solve and put it here. For that, let me see if there is some easy method we can see. dV by dt, this will be in the form of PV is equals to nRT. So that will be V by T is equals to nR by P. Okay. If you put the value of P from P here, it is going to be P is equals to K by V raised to power n. Right? If you put the value here, nR, P is nothing but K V raised to power n. k divided by v raised to power n, right? So here v by t is equals to nr by t. This is v raised to power n, right? So v 1 minus n by t is equals to nr by t. P is equals to k. V by t is equals to nr v raised to power n divided by k. So this will be v. If you solve this, 1 minus n, right, divided by t. This is nr divided by k. And we just need to calculate the value of this, not in terms of that. So let me see what is the easy way of doing this. See, basically what you have to do is from these two equations, you have to get the value of dv by dt, which easily you can differentiate, right? So here what they have done is k multiplied by v raised to power 1 minus n. K value is nothing but k is equals to k, they have directly put the value, right? V raised to power n minus 1 is also, they have directly put the value, right? Okay, from that they are solving this dv by dt. K v raised to 1. So I'll do that not like this. PV raised to power n is equals to k is a constant. Then PV is equals to nRT. Give me a minute. PV is equals to nRT. Let us solve this value here, right? P value is nothing but it is k by v raised to power n. This is P is k divided by v raised to power n. This is v. This is nRT, right? So here it is v by t is going to be nr. This is divided by k. This is v raised to power n, right? V raised to power n here, right? Okay. So you have to solve this value here, right? That is going to be, if you put this value here, this is going to be v. This is 1 minus n. This is nr. This is t. And this is k, right? So to solve this like here, this will be v 1 minus n dv here and dt here, right? That will correspond to 1 only, right? So this will be nr divided by k, right? And this will come out to be nahi yaar, it is not coming out to be correct. I don't know why, where I did. Let me see. Chalo, I'll give it 2 more minutes, then I'll have to move to the next question, right? Because here's something I don't know. I just solved this before also. Totally right now I am finding it little twisted, right? PV is equal PV by P value is this, P is this. By that also you can solve this, right? Or there is something wrong here. Wait a minute. I think I was solving it right only. Hai na? If you got it dt, this will be n, this will be 1 minus n, 1 minus n, v raised to power 1 minus n minus 1. That is 1 minus n, v raised to power minus n. Okay, let me see. This is nRT divided by k. Because in just one step, we can't solve that, right? So this is 1 minus n, 1 minus n. This is v raised to power minus n. This is dv, right? So dv by dt will come out to be nRT by k. This is 1 minus n. This is v raised to power minus n. Let me see nRT by k. Sorry, no, not t. T will be the constant, na? T will be cancelled out here. T was constant. Wait a minute. T was constant here. So T will be cancelled out. T was constant here. So T will be cancelled out because integration of T is going to be eventually 1 only. Right? So that will be cancelled out. So here it is going to be NR. This is dt. This is NRK. Let me see if our answer is correct. Yes. Okay. So dv by dt will come out to be nr by k 1 minus n. So basically what you have to do from these two equations, here so they have written directly, but actually you have to go through this method. First you have to solve the value of p from here, then put it here, right? Then do the differentiation integration here, and after that you will get your answer. Okay? After that you will get your answer for dv by dt after solving this, right? So this is what you will get the value of dv by dt. Then dv by dt you just have to put it here, right? When you put the value of dv by dt here, what will happen? This will be p dv, this will be p by n, and this is nr divided by k 1 minus n v minus 1. So n and n will already eventually cancel each other, right? Okay, and here after solving this, right, from the equation 1 and 2, like put these values here and this will become p, this is r, this is k 1 minus n v raised to power minus n. Okay, this is what you will get here, and after this you will just have to go through the options here and you can see what is your correct answer. Okay, eventually also directly also you can tell that what is the correct answer, right? So answer will be B is the correct, that is R divided by 1 minus N. Okay, understood? Yes, everybody. So directly you can see what is your correct answer here, right? Here K value we already know, PV raised to power N. You can put it here as well again. That is PV raised to power N. These two will cancel each other. This will cancel this P here. So answer will be equals to R by 1 minus N. Right? So answer will be D is the correct answer. That is R by 1 minus N. Okay? Understood? Next question here is, I think this is the last question maybe. A cyclic process is shown in PT diagram. So in this diagram, they have given you cyclic, which is the curves show the process of VT diagram. So this is actually a simple question for your JEE Advanced, I would say, but you need to know the core concepts here. So basically, if you have to see this, you have to go through each of the lines here, each of the processes here. A to B, we know that this is not pressure is constant, not temperature is constant. So what I would rather suggest you go through either AC or BC, right? So I would firstly prefer BC here. In BC process, we know that pressure is constant. So here, any case, no, not pressure, here temperature is constant. Here in any case where temperature is constant, for BC, temperature is not constant. Here temperature is constant. Here temperature is constant. Here also temperature is constant, right? But here what you will see that here BC temperature is constant, but here pressure is decreasing, right? In this case, what you will see, volume is increasing, pressure is decreasing, right? Here volume is increasing, B to C volume is increasing, right? And pressure will be decreasing, right? In this case, volume is decreasing and pressure is increasing in this case, right? Okay, that means this option is also eliminated. Now look for this option here and this option here. Either of them is the correct answer. Now let us see AC here, right? AC here, temperature is changing. AC here, temperature is not changing. AC here, what you see, here also AC temperature is not constant, but what you will see here, pressure is constant. For AC, pressure is constant. We just need to see that case where pressure is constant for AC, which also we can't identify. So let us see for AB. AB is temperature is changing. For AB, here also temperature is changing, right? Okay, here temperature is increasing. Wait a minute. Here temperature is increasing. Here temperature for AB, that is also changing, right? Here for AB, temperature is changing. Here also temperature is increasing. But I would think that in this case, BC volume is increasing. Wait a minute. Here volume is increasing. Here volume is increasing. No. In this case for BC, CB volume is increasing. Wait a minute. This is opposite. Otherwise, so we can't differentiate between these 2 points, right? There is no other point of differentiation here. Right, so CB volume is here, we can see from CB volume is increasing. For CB, if volume is increasing, then for BC volume is decreasing, that means pressure is increasing. So again, this is not the correct answer. So answer will be C is the correct answer. Right, so you just have to do hit and trial method. Right, you have to see each line here, right, which is matching which thing. If you can't see a proper match here, then that is not the correct answer. Here we can see a proper match with respect to the pressure of BC. That is why C is going to be the correct answer here. Is that clear to everybody? Right? Okay. So guys, that's it for your JEE Advanced questions, right? And I'll also start taking previous year questions of JEE Advanced, and let me know in the comment section if you want JEE Advanced previous year question like set by set. Set by set means like 2-3 chapters combined, right? And also let me know if the chapters that were not there in JEE Mains, if you want me to take up short, not lectures, I would say just questions and some short notes based on that, right? If you want that, then let me know in the comment section. According to that, I'll do that, right? Okay, yes. And before going, all the students who want to prepare for JEE Advanced, right, and in a dedicated lecture, then students, we have this Eklavya batch for you. You can see this, join the Eklavya batch, right? In this, basically, JEE Mains to JEE Advanced level, one of the students was asking, ma'am, if our basics are strong, then can I crack JEE Advanced in 30 days? So that is possible, but for that you need a proper strategy, right? You can't apply hit and trial method at this point. For proper strategy, this batch is currently going on, that is JEE Eklavya batch, right, where proper discussions daily, the day to night it is going, right, from Eklavya book, and these questions were also from Eklavya book only, right? Okay, and all the previous year questions are also discussed in this particular batch. And for those students who are like, ma'am, my basics are really strong, ma'am, I just want to revise the questions, then this rank accelerator book is for you. That is physics, chemistry and mathematics rank accelerator book. That is just at 1665 for you. All the 3 books will be available to you, right? And that will be delivered at your home, right? So still you have time, right? And that's it for today, students. And for other exams also, VIT EEE and all the other exams, I'm going to take up lectures in this week only, right? For VIT EEE also, so many students were saying, I am taking the lecture, don't worry about that. I'm taking one lecture on that as well in this week only, right? Okay. So, okay then, bacha, bye-bye, take care. I think this is the time for your mathematics class. Bye-bye, take care. Till then, see you all in the next classes. Bye-bye, take care.